then we come to different types of innovations, and as you perhaps already have seen around you, there's a lot of things that are called innovation today. So there are different innovations in different areas. There are technological innovations that are technology based. There are organizational innovations, that means new organizational processes, new structures of organizing, new forms of organizing. There are social innovations, that are new strategies that meet the needs of different social problems, improving working conditions, bringing education to those who do not have that in a new way, things that strengthen the civil society in different ways, and that might not include gaining money out of the innovation. And there's also business model innovations, where you invent new ways of bringing value to clients. And there are also legal innovations, where you make new laws that hopefully make it easier to regulate the society in a good way. But we will focus on technological innovations in this course. And when you look at technological innovations, there are different types of those as well. There are incremental and radical innovations, and that can also be called continuous or discontinuous or disruptive innovations. Then there are architectural and modular innovations, competence enhancing and competence destroying innovations, product and process innovations. If we start with incremental, that is, incremental innovations are made to established products and processes, and that can create new product offerings and meet customer needs in established markets, can enable product life extension, and can improve processes to enhance quality and or reduce cost. So it's smaller changes to an established product or process. And if we look at this graph, in this graph you see incremental innovation. This is basically that we have some kind of innovation here, something new, perhaps a product, and in time incremental changes are made to this product. It becomes better and better, and the performance that you see here becomes higher and higher as time goes by. And this usually follows an S-curve. Slow development of performance in the beginning, when you kind of decide on what this innovation will look like, what kind of dominant design will there be, but then more rapid improvements to the performance when you know what the innovation is and what it will do, what attributes it will have. So lots of improvements in the performance here, and then after a while you reach some kind of physical limit of technological performance here, and then this S-curve fades out, and then you will probably have some new innovation taking over, and we will talk about that later. Then we have radical innovation, and that is something that changes the structure of an industry, changes the terms of competition in an industry, and may threaten established firms, and can create entirely new industries. It's something that is substantially new. It's not something that just improves an existing product. It changes the entire market. Here you see the radical innovation. What that is. That is basically something new that happens. You remember this S-curve from when we talked about the incremental innovation? Here we have performance again, and here we have time. We had this S-curve, some innovation here, incremental changes that end after a while when they reach the physical limit of the old technology. This will be the old technology then. During this time, when we reach this physical limit, there will have been things going on here. Perhaps things have started in some kind of niche market, perhaps developing something new. And here, for a short while, two technologies will coexist. Here, something new has begun to be developed. So here, this will be some kind of period of discontinuous change. Something will happen here. And in the beginning, this new innovation will have lower performance than the old. But as this S-curve starts with lots of incremental changes, this new innovation will get higher performance than the old one. And a new paradigm, technological paradigm, has started here. And after a while, the old users of this technology will all have left and started using the new technology. At least theoretically, that would happen. And the radical innovation is this kind of change where there's actually a new S-curve coming with a new, something radically new here. It's not the incremental changes of the existing product or the existing product that you see here. It is actually something entirely new that then is subject to incremental changes and incremental improvements, incremental innovation, until that innovation reaches its physiological limit of the performance. And here we have the relationship between product innovation and process innovation in a graph. Here we have the rate of major innovation. Here we have three phases: the fluid phase, the transitional phase, and the mature phase. So we have the product innovation. In the beginning, there's lots of innovation activity here. Before the dominant design is set, and you do not know exactly what kind of product this will be, the rate of major innovation is then high in the beginning for the product. But as you have decided what it is, the rate of major innovation goes down, and we have smaller and smaller incremental innovations here. Going into the transitional phase, and then after a while into the mature phase, where we have very low rate of major innovations, mostly incremental innovations. But if you look at the process innovation, and that would be the way in which you manufacture this product innovation. In the beginning, where you do not know exactly what the product will look like, there is not a lot of major innovations in the process, because you do not want to invest so much before you know what it is that you are going to produce. So this could be kind of made in an existing facility that is designed for some other product, or it could be still developed in the lab, manufactured in a lab. But then after a while, as you start to getting a grasp of what it is you're actually doing, you invest more and more into the process, making the process smooth and reducing the costs perhaps. And then in the transitional phase, that is when you get a high rate of major innovations in the process. But after a while, you have reached a kind of decline in the process innovation as well. And the rate of innovation goes down, and in the mature phase, you have mostly incremental, smaller changes and smaller innovations as well. I mentioned the dominant design when I talked about the process and the product and the different curves for them and the change of the rate of innovation for both of them. And dominant design is the thing when the community of innovators and firms have kind of reached a decision in terms of what the innovation will look like. In the beginning, you will have a number of different ways in which the product will look. And here we have examples of the bike. It looked quite different from what it looks like now when it was in the fluid phase. It was a number of different ways to construct a bike. But after a while, after testing all of these, you can read more about it in the article that I referred to here from Pitch and Biker. They ended up with a dominant design, with the classical way to view a bike that we have now. And here we have another way of looking at it. It's called the technology cycle. Here we have another way to look at it, the technology cycle. You would have some kind, if you look at it, it's similar to the other graphs. First we have an era of ferment, where it's design competition, it's substitution, you do not know exactly what you're doing, it's some new technology that has entered the market, it might still be in a niche, it might be competing with an old proven technology. But after a while it goes into this phase where the dominant design is selected, and then it goes into an era of incremental changes. Then you basically elaborate on the dominant design, and there's a lot of incremental changes to improve the product. But then there is some technological discontinuity, meaning that a new product enters the market, challenging this existing product. It's in, as we saw in this graph, this area of discontinuity, where there is a new S-curve starting, and that is basically the same as this phase, where you go into a new era of ferment with a new S-curve, with a new innovation, and the circle goes on like that. So it's another way to look at it. Then we have architectural and modular innovations. And modular or component innovation, that entails change to individual components, but not the way in which they and other components are configured. And one example of that would be changing the bicycle seat technology, changing to a more comfortable seat on the bicycle frames. That does not entail any changes in the other components of this bicycle, only this one component is changed. But if we consider architectural innovation, that entails change to entire architecture design of the product. The components might remain the same, but the way they are configured change. And one example of architectural innovation that is also found in the book, that is the transition from the high wheel bicycle to the safety bicycle. So basically, the old bicycles from the 19th century, they had big wheels, and the size of the front wheel directly determined the speed of the bicycle. But then there was new technology that enabled the bicycle to have a fine chain, as you might know that now bicycles have a chain, and that enabled two equally sized wheels instead of this one big wheel. So this new technology changed many components of the bicycle and the way in which riders propel themselves. So that was an architectural innovation. Then let's consider competence enhancing versus competence destroying innovations. So competence enhancing innovation, that is improvements in price and performance that builds on existing know-how within a product class. So you have some kind of competence, and new things that are developed kind of leverage that competence. So it enhances your competence, you build upon your competence. But then we also have the competence destroying, and that means mastery of the new technology fundamentally alters the set of relevant competences within a product class. So the new technology is so fundamentally different that your competencies are not relevant anymore, and they're not relevant for anything when this new product is there. Therefore, your competence it's destroyed. You do not get to enhance it and improve upon it and use it. And one example of this is this slide rule that you see here in the slide, this yellow thing. In the 1600s, this was developed and it was used until the 70s. And it was used by mathematicians and engineers to calculate things. They are lightweight devices, often constructed of wood, that use logarithm scales, and you can use that to solve complex mathematical functions. So they were used everywhere to calculate structural properties of a bridge and to use it to calculate the range and fuel use of an aircraft, for instance. And during the 50s and 60s, Köffel and Esser was a prominent slide rule maker in the United States. They produced around 5,000 slide rules each month. But then in the 70s, a new innovation reached the market that was devastating for the slide rule. This slide rule basically ended up in museums after this innovation entered the market. And that innovation was the handheld calculator. And Köffel and Esser, who produced the slide rule, they had no background in the electronic component industry. So they could not go into making electronic calculators. So they were unable to transition to the new technology. And by 1976, Köffel and Esser had to withdraw from the market. But the inexpensive handheld calculator, it built on the existing competencies of companies such as Hewlett-Packard and Texas Instruments. So for them, this new innovation was a competence-enhancing innovation. But for Köffel and Esser, the calculator was competence-destroying.